In this video, I'll discuss how to recognize bash scripts. In Linux, a shell script allows us to place many Linux commands within a single file, and we can run all of those commands by invoking that single file. So it's a great time saver for repetitive command line tasks. On my Linux system, I'm currently in the scripts subdirectory. We can verify this by typing pwd. If I type ls, I notice there are a few scripts that already exist here. So I'll use the cat command to display the contents of a file called script1.sh. Scripts do not have to have a .sh extension. The first line of my script reads !bin/bin/bash. Every script should begin on the first line with a statement that identifies which shell should be executed to run the commands in the script. Here we're specifying a bash shell, but in Linux there are many other shells that we might be using at the command line, including the corn shell, the C shell, and so on. We can execute this script from the current directory by typing / and then specifying the name of the script file. When I press enter, we can see that the script executed and it's showing me the last 10 lines of the system log file. I'll use my up arrow key back to where we can see the contents of the script, and indeed it's using the tail command to show me the last bit of /var/log/messages. I'll clear the screen, but this time we're going to use the cat command to display the contents of our second file called script2.sh. This one is a little bit different in that it's got different commands. It's using the setenv command to display environment variables. However, notice the first line of the script identifies bin bash as the shell. The problem when we try to run this is that there is no setenv command to display environment variables in the bash shell. But let's see what we get when we run the script. So to run that script from the current directory, I'll type / and I'll specify the name of the script, in this case script2.sh. The script runs, but it tells me that the command was not found for setenv. That's because that will work in a C shell but not in a bash shell. So we can see the relevance of that first line in the script that identifies the shell to run. Let's make a change to that file. I'll use the gedit graphical editor to open up the script2.sh file, where I'm going to change the first line to read !bin/csh. That will start the C shell. Now it has to be installed, which it is on this Red Hat Enterprise Linux system. This means that the following commands in the script will be running within a C shell environment. So I'm going to close and save this script, and I'll use my up arrow key so that we can execute script 2 once again. This time, notice there's no error message. Instead, it's running the setenv command, which shows me my environment variables. In this video, we learned how to recognize bash scripts. In this video, I'll demonstrate how to create a simple bash script. Scripts are great because they save time. We can put a bunch of commands within a single script file and then invoke the script file. The first thing to think about is what your plan is. What will the script do? Scripts might be just a few lines long, or they could be hundreds of lines long and very complex. Sometimes it can be helpful at the command line to type in some of the commands you're going to want to put into the script to make sure that they're correct. We're going to build a script here that writes the date to a file along with a list of users logged into the system. And we want to make sure we keep appending to the same file so that we kind of have an audit log of user activity. So the first thing I'll do is type in the date command, which returns the date and time. That information needs to be written into a file along with the result of the who command, which shows me who is logged in. The next thing I have to think about is which text editor I'll use to build my script. I'm going to use the standard Vim text editor in Linux. So I'll type vim space script3.sh. My new script will be called script3.sh. I don't have to use the .sh file extension for the shell script, but it often is done in Linux and I'll stick with that standard. So I'll press enter. Now I'm in the Vim editor with a blank slate. I'm going to press Insert to go to Insert mode so I can add content to this file. The first line in any script should always be the shebang line. The shebang line identifies which shell needs to be spawned to run the rest of the commands in the script. Because we're writing a bash script, we need to specify the bash binary program. To do that on the first line in our script, I'll type #, exclamation mark, /bin, /bash. Then I'll press enter. The next thing I want to happen is I want to use the echo command to echo back a series of asterisks just as a delimiter between sections in the file. And I want to append that to a file, so I'm using the double greater than sign, which is the append operator. And I want that to be appended to a file called user activity. The next thing I want to do is write the date out to that user activity file. And I'm going to use my append operator again. Then I want to use the who command, and I want to append the list of logged in users, again to the user activity file. I'm going to go ahead and press escape to go back to command mode, where I'll type a :WQ to write and quit that file. If I cat the new file that we've created, that would be script3.sh, we can see the contents are stored in that file. If I try to run that script with ./script3.sh, I get a message that says permission denied. And that's because if I type ls-l, we can see that nobody has execute permissions for the file. Not the owner of the file, they don't have execute permissions, we've just got a dash in that place. The owner here is root. Nor does the owning group have execute permissions. The owning group here is root, nor does anybody else. So nobody has execute permission. Scripts need to be flagged as executable. Here, I'll do that using the change mode command, chmod. So my command will be chmod space +x. I want to add the execute permission for everybody. And the last thing I'll do is specify the file against which that operation should be conducted, script3.sh. If I do an ls-l, we can now see that the color of the text for that file name changed. It's green, which implies executable. And we can see, in fact, the execute permission was added for the owning user, for the owning group, and also for everybody else. Now, we can type // with the name of our script, and it will execute. Now, nothing showed up on the screen because in our script, we've taken all of the output and appended it to a file called user activity. If we do ls in the current directory, we see, in fact, the presence of the user activity file. I'm going to use cat against that file to see what's in it. You'll notice that we have our line of asterisks, we have the date and time, followed by a list of users who were logged in at that date and time. In this video, we learned how to create a simple bash script. In this video, I'll demonstrate how to execute and control scripts. Here in Linux, I'll type cat space script4.sh so that we can view the contents of this sample script. The first line of the script uses the echo command to display the text, "The script is now running." Then there is a while loop that is endless, and within that loop, it is finding files from the root where the permissions are set to 777 and the owning user is root. The results of the find command are being sent to dev null in this example. If I type ls-l, I can see for the script4.sh file that the execute permission has been set for the owning user, which is root, the owning group, which is the root group, and for everyone else. You need to flag a script as executable before it can run. If I were to type script4.sh to attempt to run the script, I would get a message that says the command was not found. Even though we're in the same subdirectory with the script, unlike a Windows environment, it doesn't search the current subdirectory. What it's doing is checking the path. If I type echo $path to view the contents of the path variable, we see a number of subdirectories, each of which is delimited or separated with a full colon. So when we type in the name of a script or a binary program, Linux will search the path from left to right. Now we could modify the path, or we could call the script in an alternate manner. For example, to run the script in the current directory, I could type ./script4.sh. Now what happens here is the dot means current subdirectory, and then I'm simply telling it the reference of the file name within the current directory. When I press enter, we can now see the script is running. I'll terminate that with Control-C. Alternatively, we could type the full path to that file, so /userfiles/scripts, and finally /script4.sh. I'm giving it the full path to that file. And once again, we can see, of course, it works correctly. The script is running. I'll terminate that with Control-C again. This time, I'm going to make a change to my path. I'm going to type path equals $path. So I'm setting the path variable to equal what it currently contains, and then I'm going to add a colon and /userfiles/scripts. So I'm adding a new subdirectory to my existing path variable. Let's bring back the echo $path statement using the up arrow key to verify that at the end it contains /userfiles/scripts, and it does. This means then if I were to go to the root of the file system with cd // I should be able to type script4 from here and from anywhere, and it will run the script because it's in the path now. Now bear in mind that that path variable change is only in effect within this shell. I would have to make a change to one of my Linux startup files, like my profile script, to make that a permanent change. I'll press Control-C to terminate that script. I'm going to run the script again, but this time at the end I'm going to add an ampersand symbol. When I add the ampersand symbol, I'm telling it I want to run that script as a background job. So when I press enter, instead of it taking up my command prompt so I can't do anything else, it gives me a job number, in this case job number 1, along with the process identifier or PID, in this case 26576. It tells me the script is now running, but it's running in the background. I can verify this by typing in jobs. Here I can see all of my background jobs, and I can see in fact job 1 is running, and it was spawned from the command script4sh &. I can bring that job to the foreground if I need to. I would do that by using the fg command. So I'll type fg #1 to bring job 1 to the foreground. We can now see that we no longer have our command prompt because we brought that job to the foreground. I could press Control-Z to temporarily suspend that job. Now it returns that the job was stopped, and in a sense it has been stopped, but it hasn't been terminated. If I type jobs again, in fact we can see job 1 is still in a stopped state. I could even start that job again if I wanted to. For example, I could run it in the background by typing bg #1 because it's job number 1. Now, if I run the jobs command again, in fact, I see job 1 has continued running. Now, we know that we can terminate a running script if it's in the foreground by pressing Control-C, but what if it's in the background? Well, we can use the kill command given its PID. So here, I'll type in kill #26576. That's the process identifier or PID that was assigned by the kernel when I spawned the script. I now get a return message that tells me it's been terminated, so if I type jobs, there are no longer any background jobs running. When you use the kill command as we've done here, it does gracefully terminate that script. In this video, we learned how to execute and control scripts. In this demonstration, I'll work with shell variables. In Linux, from a bash shell, we can type the env command to display environment variables. We could also have issued the print env command to do the same thing. When used without command line switches, env and printenv report the same information. That information includes variables. For example, if I take a look at the home variable, I see the name of the variable, home, on the left, followed by an equal sign and the value on the right. Often in Linux, variables are referenced in uppercase letters. So if I wanted to display the contents of the home variable at the command line, I could type echo $$ and then put in the name of the variable. Remember to use uppercase letters if the variable name was created with uppercase letters. So we use the $ as a prefix when we want to extract the value within a variable. But we can also build our own variables. For example, I want to build a variable called location. So I would type in location equals, and in quotations, I'm going to put in the city name of Brussels. So I only use the $sign with variable names when I want to extract the value. So here I'll type echo $location, and indeed it returns Brussels. But what I'm going to do now is type in bash to spawn a new subshell. It doesn't look different, but I've now got a new instance of the bash shell running. If I try to type echo $location, this time it doesn't return Brussels. And that's because the scope of a variable in Linux by default is within the current shell. I've just spawned another bash shell, so the location variable doesn't exist here. I'm going to type exit. That puts me back in my original bash shell where, if I use the up arrow key, I can echo the location variable and indeed it returns Brussels. If you know you've got a variable value that you want available in subshells, you can export it using the export command. Here I'll type export space location, which is the name of my variable. I don't use the $sign though. So I'll start another bash subshell again by typing bash. And once again, what I'll do is type echo space $sign location. Now, because I've exported the location variable, it now has a value. It exists in all subshells. Whenever we start a shell script in Linux, we are spawning a new subshell. So exporting variables can be very important in that case. Let's use the cat command to view the contents of the script3.sh sample script file. Here in this script, it is writing the date and a list of who is logged in or appending it to a file called user activity, and then it echoes back the location is, and it uses our location variable. So what I'm going to do is execute that script from within the current directory, and I can do that with / and the name of the script, which in this case is script3.sh. When I run the script, notice it returns the location is Brussels. This means that when the script ran and it spawned a subshell, our exported variable location was visible to that script while it was running, and that's why we got the value returned correctly. If we start a C shell using CSH, we can also use the setenv command to display environment variables. We can also use setenv to create variables. Here I'll type setenv space dept space in quotes HR. So I've created a department variable that has a value of HR. So I could use the echo command to display the contents of that variable. The setenv command is specific to a C shell. It won't work in a bash shell environment. In this video, we learned how to work with shell variables.